So yeah, welcome everyone to the workshop today on smart contract security and tokens. So the agenda for today is like we are going to discuss two stuff. The first one is smart contract security. So yeah, we go into like the past attacks on Ethereum blockchain, and then how people they have mitigated or prevented such attacks. And yeah, they're going to some exercise for you guys to attack a contract. And the second thing is like we discuss about fungible tokens and non-fungible tokens. So yeah, um, so in the middle of the in the workshop, if you have any questions, so yeah, feel free to ask me and mute yourself or just leave any question in the chat. So yeah, I'm going to start for now. Yeah. So first thing, let's talk a little bit about smart contract security. Yeah. Yeah, I want to tell you guys a little bit about uh, like the Ethereum horror story. Like, yeah, there are some really interesting stories in the past that some smart contracts have been attacked on Ethereum, and yeah, it cost them millions of dollars back then. So yeah, the first one is the DAO hack. So if you don't know the DAO, so it's just like the DAO DAO. So it's an abbreviation for the word decentralized. Um, so an decentralized autonomous organization. So you can imagine it's just like a representation of an organization in the form of the code that live on Ethereum. So like they will be in the form of smart contracts. So yeah, so if we have like the rules and then the roles for people to play as and the rules for them to have to have to live by, like have to follow. Yeah. So the thing is the DAO back then in 2016, right? So Ethereum it launches, if I remember correctly, like in 2014 or 2015, right? So the like in 2016, Ethereum is still new, and the DAO hack is one of the most popular application. Sorry, the DAO is one of the most popular application that stay on Ethereum. And yeah, so however, some hackers they found out uh, ways that they can exploit the fund of the organization. So they just put like about 2 million of ether. So its value is about back then was about 40 or 55 million out of uh, like 11.6 million ether. So like about 15 of our ether in existence back then. And so and as a response, some so because if we're such a really large amount in the for like in the whole Ethereum supply, so the community they gathered together, and they decided that they are going to make a hard fork. And yeah, so it's just like they split into two chains. One chain is the one that has the attack, and another chain is the one that doesn't have the attack. So yeah, so this attack it results in two chains. One is called like Ethereum, and another one is called Ethereum Classic. So Ethereum Classic is still in its existence today, and yeah, so like Ethereum Classic, yeah, they just argue that like whatever happened on Ethereum on blockchain just let it be. So yeah, they are hardcore decentralization guys, I guess, and yeah, they are still supporting Ethereum Classic today. But the Ethereum chain that we know today is the one that has been forking out of the attack, so it doesn't have the attack anymore. So yeah, that is the main chain that like people follow today. Um, and the next attack is called Parity Multisig attack. The Multistick here it stands for like multi-signature wallet. So it's just like a wallet that have like let's say like a wallet that let's say it's a wallet to a fund, and in the fund like they have like for people back that wallet. So you need to have like at least two or at least three to sign on the wallet, like yeah, signature to for the wallet to transfer the fund out of it. Okay, and so yeah, so the thing is like about like about one. Sorry. Oh, is it clear for now? Can you hear me? Okay. Is it stable for now? Can you hear me for now? Hello? Hello, hello. Is there any sound? Hello? Uh, so I'm just, yeah, never mind. So I'm just continue. So, like 150,000 K of Ether was stolen in like from Parity Multisig hack. And yeah, so the white hackers, the rescuers, like fortunately, they can drain the remaining funds and return them afterwards. And one notable thing about it is like the contract was actually written by Gavin Wood. So you know this guy, he is the co-founder of Ethereum. So yeah, so even the co-founder of Ethereum, they made some mistake when they first like when they wrote their first smart contracts. So yeah, a really ironic thing, like yeah, uh, and ironical thing. Yeah. And then after the hack in July 2017, right? So um, the company we had the multi-sig wallet. It's called Parity, and they put other face on like for the wallet. But again, it contains a new bug. And yeah, in 20 like in November 2017, right? Someone accidentally killed the library that many other wallets depends on. So they freeze about like 310,000 K of Ether. So a really large amount. And yeah, so yeah, if you notice on this picture, right? So the guy is like this is like the GitHub repo, like one of the GitHub. So this is just like one of the GitHub comments on the code. So one that the guy posted on GitHub there, like he just like said that, oh, I accidentally killed it. And then yeah, so that's a really funny thing. Like somehow the guy is new. It seems the guy is new to smart contract stuff, but in some way he has the ability to hack it, like just do something with it, and then yeah, make the second attack on the multi-sig wallet. And like so to so for the attack, like so in the same way as like Ethereum Foundation they did with like the split between Ethereum Classic and Ethereum. Yeah, the Parity company they proposed a proposal that yeah, to propose a hard fork, so to fork into two chains again. But this time the community strongly rejects it. So yeah, it doesn't come through. It didn't come through, and yeah, the fund was like permanently lost. Yeah. So yeah, and and the last attack I want to talk about is like the FOMO 3D attack. So this is actually a gamble. Yeah. So the aim of the game is that for you to be the last person to have purchased a ticket from the smart contract of the game. And yeah, so when a timer to go to zero. So now like a thing that makes this game hard to finish is that every time one they purchases a ticket from the smart contract, it will increase its timer by like 30 seconds. And yeah, and it seems that like it's hard to be hacked, but actually a smart and diligent dude do that. And the way they do that is the one of the they actually have a lot of tactics in achieving this, but the most notable one is that when the time of the game they reached about like 3 minutes, and the winner they bought one ticket, and then they like they don't allow other people to submit like the transaction to purchase a ticket anymore. The way to do that is like they send multiple high gas price transactions to yeah their OT apps. So because if you are familiar with Ethereum, like the miners we one of the one of the main incentive for the miners to include your transaction is like for the miner is the transaction fee that you are willing to pay them. So the miner, when they see like a high transaction, like the miner, they will prefer the high transaction fee transaction. And yeah, so as a result, the miner, they only include the transaction of the attackers because they have the highest gas price compared to other transactions. So yeah, no one can purchase a ticket anymore. So and as a result, uh, yeah, he or she won the gamble and receive a lot of money. So about 10,000 either, yeah, by executing the attack. So yeah, a really outstanding move. Yeah, really smart. So yeah, so with that, it ends the attack like the Ethereum auto story. So now I want so let's move on to how can we mitigate or prevent such attacks. Yeah, are you guys okay for now? Can I move on? Any question? Oh, it's okay, right? Yeah, so all right. Yeah. So, so the first thing is let's first talk about like one of the basic ones first, and then we can move on to like more, let's say more sophisticated one. Yeah. So the first thing is about the overflow and underflow bugs. So yeah, this one is really common in like any programming language, and in such like in like a language like that is serving critical purposes like in Solidity, it is more and more important. So like for Solidity version that is less than 0.8. So let's say when you increase like an integer like that is that it is be larger than its range, then it will wrap around, which means like let's say you increase like the number to be too large, so then it will wrap around and be equal to zero for undefined integer. Yeah, so Yeah, like the same applies for other cases when you like which is over like under the medium value. Yeah. So yeah, so you can notice in this contract also like these requirements to be fairized. So the first one is the required like um, so the maximum of unsigned integer that have 8 bits plus one larger than one. But the thing is like when you increase it over its maximum, it will return to zero. So it will not be larger than one. So this requirement will be failed. And the same for like maximum of unsigned integer multiplied by 2 uh, is required to be larger than 1000. This requirement will also fail because it again it will wrap around and be equal to 0. And so and you can apply the same logic for the last requirement. And so one way we can fix this one is that we use a library called SafeMap by Open Zeppelin. And yeah, so it's like this Open Zeppelin that they have like a collection of libraries that you can use, and they are like because it's open source and has been audited many times by a lot of developers. So yeah, you can entrust it like to execute your logic. So one of the like one and like the operation like add, multiply, or divide, etc. Is one of its libraries, so you can use that. So one example on how you can use that is like you just import the library and then you let's say you want plus add a and b, then a dot add b, or like add b and c, then b dot sub c, like that. However, luckily, like in just like last, uh, so in November last year, Solidity they released their version 0.8. So arithmetic operations will revert on underflow and overflow by default. So yeah, you use like the latest version, so then you don't care about it anymore. Yeah. And the second one, yeah, so is the reentry block. So this is the one that causes the DAO hack. So yeah, so yeah, you must have thought that it must really be a really complicated attack so that it can like drain a lot of fun from Ethereum. But the thing is that this attack is really simple, but it's quite smart. Uh, yeah. So what is a reentry block? It's actually like you call like you let the external contract to like to change like the flow of the to change to have the like take over the control flow of your contract. So so let's say another contract, they call a method in your contract, and then this your contract will pay this smart contract for something, and then but this smart contract will uh, and as a result this smart contract will take over the control flow of your smart contract. So let me like present to you in a form of an example. So yeah, so you can see here uh, so we have two contracts here. The right, the contract on the right is the vulnerable contract, and on the left is the attacking contract. So let's say we have. So let's take a look at the vulnerable contract first. Yeah. So this contract, so it has like the balance. Firstly, like is maintains the balances of the people in the maintains the balances of the address into Ether, and and then it has the donate function, so that like someone can donate some ether into the contract, and yeah, their balance and the contract will record the increase in their balance also. And the second method is the balance of, just to query the balance of the address. And the third one is just for the like like the holders to withdraw the money, the ether, out of the contract. Okay. Yeah, so the way this attack works is that yeah, firstly, so you can notice over here there is one function called like attack one cost overflow. And the first thing we do is like yeah, they donate firstly they donate some money into your contract. And then the second thing that we do is like the withdraw. And like one note is that the contract here, it has one special method or function. It's called like external, like you can notice the last one. So it is function external payable. So yeah, so and it's actually called the withdraw function of your contract again. So let me just continue on how attack one cost overflow works. So let's say after donating the some money into your contract, this method here, it will withdraw one ether out of your contract. And then yeah, so and this and then is this one we call the withdrawal function of your contract. And yeah, so it firstly, like you can notice, like it just check the balance of the message sender here larger than the amount required, the amount asked for. So the sender here is actually the attacking contract. And yeah, if it is yes, then the vulnerable contract will send some ether into the attacking contract. So like in this case, it's one ether, right? So if you notice here, when the vulnerable contract, it paid some ether into the attacking contract, then uh, uh, it will call the vulnerable contract. We call this function the last function. But the last function again, it called the withdrawal function. So yeah, it's actually withdraw some money out of the um, withdraw some money out of the contract again. And you can imagine that this will cause like an infinite loop, and then it will just drain all the money out of the vulnerable of the right contract. Yes, fine. Yeah. Thank you for coming also. Yeah. Yeah, Retro just uh yeah, yeah. Okay. Retro just left, so I'm just continue. Yeah, so you can imagine they would just cause an infinite loop, and then and as a result, like the variable contract will be out of money. Okay. And then how we can defend this contract is like we so so it's recommended that we should finish our internal work that before we call some external function. And yeah, so if you notice here, like the 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 vulnerable contract only deduct the balance of the sender at the end of the method. So as the result, when it check whether the balance of the sender of the message is larger than amount, then the requirement will be fine. So yeah, so this attack will not happen if we put it on the top. So yeah, um, so this is the withdrawal vulnerable, where we have like the deduction at the end. But if we put it at the top, um, then like you can imagine, right? So you deduct first and then you send money later. And then when it check games, so because your balance already is already like have some is already deducted, then it will be less than the previous one. So yeah, then there will be at a time when you cannot withdraw anymore because of this condition. Like the balance of the center must be larger than the amount that you want to withdraw. Yeah. So yeah, are you okay for this? I hope that's be fine. Question? Yeah. Okay. Okay. Uh, yeah. That you understand? It's that. Yeah. It's fine. Yeah. Then the next thing I want to cover is yeah, the multisig hack bug. So sorry. So how? So is this is the one yeah, we mentioned before, the attack. And yeah, so let's first discover how this attack happens. Um, so the vulnerable multisig wallet is actually it has two contracts. The first one is a library contract called wallet library. So it actually like contains all of the logics for the wallet. And another contract is the wallet contract, the actual one that we consume the library. So this contract is actually the storage that contains the data, and the library contract we store the logic to execute. Yeah. So this is the wallet contract, and yeah, you can see like there are three main methods here. The first one is constructor, and then we have like withdraw, and finally the payable function. As yeah, so as I like discussed before. So so let's first like see how this wallet contract works first. So in the constructor, so like you we can just like constructor it will initialize the wallet library variable will be equal to the address of the library contract. So this is the library contract here on the right, but it's not in this slide, so sorry for that. And then we will initialize the story, like initialize the variable of the contract um, by making a call from the wallet contract to the wallet library contract. So yeah, so here you can notice here, right? So it what it does is just basically like to set the owner to the address of the owner here. So yeah, and the withdrawal so and the second function of the wallet contract is withdrawal contract. Sorry, withdrawal. It's just for the user to withdraw some funds out of the wallet contract. So yeah, so it again makes some delegate call to this library contract here to execute the logic, like make some change on the logic. Sorry, to execute some logic onto the data of the wallet contract. So yeah, the wallet library is just like they contain the logic for you to execute some function, and the wallet contract is like yes to store the data. Yeah. And yeah, and the last one is that the paper function. So it's like if you have any if you have any method that does not have the like so like if you um like if the wallet contract receive any transaction like any function call, but that function name is not available in the existing method in the existing functions, then yeah, this fallback will be called, and yeah, and the fallback it will actually take the data of the message that it receives and send to the send it to the wallet library contract. Yep. So yeah, I hope that I explained the logic of the wallet contract clear. And then so let's come to the attack. So how this attack happens is like so there are some so the thing is that it's quite simple game. Again, it's a really simple attack. So actually like the attacker, they just try to become the owner of the wallet contract. And how do they do that is like they just um send some like this just send the just sends a transaction into the fallback contract here. Sorry, the fallback method or fallback function here, and the message the data of the message that they send is actually the initial wallet of this contract of this wallet library contract. And if you notice, like as I have mentioned, um, the responsibility of this of this person here is actually to set the owner of the wallet. So yeah, so by that way, the attacker like they just got wallet.init wallet attacker address. Then yeah, so they just set the owner of the wallet to be to become their address. Yeah, so then they take over the control of the fund. So yeah, that's really simple, but you know, um, yeah, it causes the loss of money, a lot of ether back then. Yeah. So with that, how can we overcome um, this attack? So actually, there are two ways to do this one. So there are two suggestions to do this. One thing is like the first one is like we can add the visibility. So only the so let's say only the only the internal method can call the initial wallet init wallet function. So like outsider they cannot call it. So that's one way we can do that. And another way is just like just we can just create a lock. So you know like the owner can only be set once, and you cannot set it again. So you cannot like reset the owner of the contract again. So yeah, we can just create a lock to do that. Yeah, I hope that's clear. And then let's come to the prevention from running attack. So yeah, this running attack is the one that the attacker they use for the gamble that I mentioned before. So we first think about like and yeah, we just firstly I may cover the basis of the like the definition of some more example of from running attack first, and then we come to the solution. Some suggestion to avoid. So the front running attack is sorry, it's really a really popular one like in the blockchain community. So it is used a lot in like let's say decentralized exchange or in ICO, or let's say can also be used in auction. So the way it was like firstly we may need to like mention the case for decentralized exchange work, especially the article crowd. So let's say we have two characters here. One is Alice and another is Bob. So Alice, she sends some order to the exchange. So let's say she wants to buy one property token for one ether. So that's her request. And if things work out normally, then there would be some guy called Bob. He would take over this order, and yeah, at the end of the like at the end of the transaction, like Alice will be returned. We have one bubble tea, and Bob we have one either. But however, let's say Alice she doesn't want to execute this order anymore. So and she decided to cancel. However, uh, uh, how decides to cancel. So like Bob like will not like then Bob will not cannot take the order anymore. So yeah. So Um, so that is the ideal case. Like Alice can cancel and Bob cannot take the order anymore. However, Bob may want to take the order before may really want to take the order before Alice cancel. So how can he do that? Is by he may use the bot and then like yeah, then the bot is just like watches all of the transaction that Alice sends to the blockchain and like and then it will find out the one that to cancel the order of the exchange. And if we monitor how much gas like the gas price of the canceled transaction by Alice. Let's say in this case we have like Alice decides that she wants to have like 20 gigawatt for the gas price. So and so the bot as a the bot sorry the bot it wants to it wants the miner to include the taking transaction before the canceling transaction. So how can it do that? It just like like um increase the gas price of the contract. Sorry, increase the gas price of its transaction. So, because uh, yeah, because the miner they are let's say they want like they want to have more money, so at the end they just take the bulk transaction instead of the Alice transaction. Okay, yeah, so that's how like a typical front running attack works. And then in general, like we have three categories of front running attack. The first one is displacement one. So yeah, yeah, okay, it's fine. Yeah. So so the displacement it's just like uh, yeah you can measure like when when there is this option for some objects, then some attacker they just like they will notice others the price of the other, and then after that they just include the transaction of the same auction price but has the higher transaction fee. So as a result, they win the auction. So that's the first one. And the second one is the assertion in assertion attack. So it is like just it's the one that we mentioned before, just mentioned recently. And the final one is the suppression of block stuffing attack. So you can imagine like when in an ICO, like so because like people they want to buy tokens first, so they just include a lot of transaction to buy the tokens with as high as high as like that has that the fee is as high as they want. So as a result of the attackers, they make they have like they will have most of the tokens out there in the token supply. Okay, and so there are two ways that we can achieve this, like two ways that attacker can use to achieve this. The first one is that they can be a miner, or and then they just reorder like however they like, however they want. Sorry. And yeah, and the second way is that they can just set the gas price as high as they want. So as I mentioned before, and yeah, so how can we defend against this kind of front running attack? So um, so the one thing we can do is like we can include the transaction counter in the contract. So so in most cases, the attacker's aim is just to inconspicuously send a transaction before the wisdom transaction is executed. So to prevent this one, you can just utilize a transaction counter within your smart contract. And whenever a state modifying transaction occurs, we can just increase the transaction counter by one. So so like when we send a transaction that you believe that could be front run in a typical scenario, then we can just send a transaction count value that dictates what the transaction counter's value should be when your transaction is initiated. So so if the transaction counter value in the smart contract is not equal to the one that you want it to be, you have specified, then the transaction just reverts. Okay, so yeah, to be clear, let me show you a contract. Um, let me show you a contract for this one. So this is this is just basically like the contract for you to set the price of the of a contract or something. So so it has constructor method, it has the buy method, and it has the set price method. So the buy here is just to yeah, just to buy the stuff. The set price here is like for the owner of the contract to set the price of the let's say of the commodity that you want to buy. So one vulnerability of this contract is like let's say like when like let's say like when the buyer they want to buy this commodity at a certain price, then our owner they can just set the price again, and when this will this may in fact increase the price that the purchaser buy the commodity at. So yeah, like the owner can just set the price before the buying transaction executes. So how how we can use the transaction counter to do this is like we can just like every time we can just increase firstly we can just initialize the transaction counter to be 0, and then and then later so whenever the owner they want to set the price again, then they can just the transaction counter just increase by 1. So and the buy method here it's just like so if we include another parameter it's called transaction counter, and it requires the transaction counter be equal to the one that the buyer has specified before he has specified in his buying transaction. So in this way, the like the buyer will buy the commodity at the price that he wants. I hope that's clear. And yeah, so another way that we can defend against front running attack is actually just limit the gas price. So like in the smart contract, there's one thing called like modifier. So it's just like a requirement that you need to fulfill to execute the method. So yeah, we can just create a modifier called like gas portal, and it will check that the gas price for the transaction, making the function call is less than or equal to what we call to the maximum gas price. And this will prevent people from seeking preferential treatment from the miners by using such a higher gas cost. And it actually allows them to jump ahead in line, but can somehow limit how much they can push to do so. So the problem with this strategy is that it needs to be supervised forever. You can imagine that if you limit the gas cost, um, then um, then maybe the let's say the um, the cap of the gas price is uh, like is reasonable for on a period like for a point in time, but it may not be too it may be too high or too low for later time. So let's say if it is too low for like for one point in time, then your TF may be completely frozen, and then because like no miner they want to take uh like the want to take in the transaction which charge a small transaction fee. Um, yeah, so they will not accept it, the transaction that the buyer sent to your the sender sent to your contract anymore. So yeah, this method has its own downside. And then we let's come to the final depending mechanism for this one. So yeah, so this one like um, it just like based on like commit and review scheme. But before we delve into that, let's just talk a little bit about like the naive one, the commit and review one. So let's say the naive ways for this commit and review scheme is that whenever you send, let's say we have an auction contract, and then people try to send the bidding transaction into the contract, and then there will be two stages. The first stage it is the the bidding. Sorry. So yeah, so it's like um so like it has two phases. The first phase is just like the bidding phase, and the second phase is the opening phase, like the revealing phase. The bidding phase is just like so like it's just like you the bidders they can just like send their bid, but like they hide value, the hide value of the uh, like they just send the hash of the value they want to bid for to the contract, and later in the revealing phase, they can just review the value. They like and people can verify the value is correct because the they can just check whether the value had the same hash as in the bidding phase. Okay. Um, However, this this mechanism like has many disadvantages. The one problem is that it cannot hide the function being called, which in this case is bidding method. And the second thing is that it cannot hide the trace of the option contract. And finally, even if someone makes a legitimate bid, there's no mechanism to enforce that he or she will pay the winning, or like when he or she to be paid when they win it. like the winner, they can just submit as many bits as they can, and then later they can choose to review to uh, review selectively. Yeah. So uh yeah. So yeah, that's the thing. Um, yeah, and so so however, this is this one like sorry. So this one yeah, but from this one we can create another advanced another advanced protection scheme. It's called like Submarine Scent. So it actually like in this scheme it has two more phases. Sorry, it has about four phases. So it has preparing phase, commit phase, review phase, and unlock phase. Um, yeah, so the key idea is that it uses the k anonymity k anonymity like um, properties like they can just they will try to hide the commit transactions as a just like a normal transaction to like to any other transaction, so that the attacker they will not know whether this is the transaction to the auction contract or to this is the transaction to the ICO or not. Okay, so yeah, so this one is quite complicated. So yeah, actually I'm just yeah I'm just present here just for your like just for you to know that there is such a way to prevent the front running attacks. So you don't need to like understand it really deeply, but anyway I'm just presented here. So like um how this defense happens is like how this mechanism work is that firstly um, the reader or like the user they can just prepare some commit prepare their commit address and their unlock transaction, and then later in the second step, which is commit step, they can just send the transaction commit to the commit address that they have prepared before, and then later in the review stage, the user they can just send the transaction review to, let's say, the Leaf Submarine, which is the yeah the contract we want to protect here, and yeah. So when like if you, so the commit address here it will be a new address, so no one knows like so like the attacker they will not be able to differentiate between like the transaction commit with other normal transactions. So yeah, so that's why the attacker they cannot try to front run this front run this transaction. And later in the review stage, the user can just like send the proof to the Leaf Submarine contract, say like yeah that I just committed this amount before in the committed stage, and yeah here my proof, and you can just withdraw the money out of the committed address. So and yeah, after receiving the funds, and then the Leaf Submarine contract they just execute the logic and decide what to do next. So that's basically the scheme. Uh, yeah. So again, some properties here like usually they don't have the private key to commit address, thus they cannot back out once they commit it. And the transaction commit is actually indistinguishable from a normal chain, a random contract from either transaction. So as I mentioned before, like because the commit address, it's just like some random address out there, and again the commit transaction is just like some random transaction out there. So only the so therefore like only this submarine does the DApp, they can take the winning bid money, so they can take the money out of the commit request. The user, they cannot do it. They cannot withdraw the money out of the commit address. Yes. However, again, this scheme also has its own disadvantages, like uh, like despite the fact that it can be used in like auction or even decentralized exchanges, um, because like this it requires a lot of steps to fulfill, and yeah, so in the best case, like it will take you two blocks in the blockchain. One is just like for the commit transaction, and another is just for the reviewing transaction. However, in reality, it may like spread out across more than two blocks. And yeah, again, it is still vulnerable to some information leaks in the review stage. So yeah, so that's it about like so that's all about like how we can avoid like the front running attack. And yeah, so up to now um, like we have covered like about like for security hacks and how to prevent it. So like overflow and the flow, we have like the reentry attack, we have the multi-sig hack, and the final one is the front running attack. So however, there are also a lot of other smart contract good practices that you need to follow when you code. So let's say it can be like you try to keep the contract simple, as simple as you can. So more complexity will be equal to more attack vectors that the outsider they can utilize. And yeah, and before you launch your contract into the production stage, make sure that it will be audited and tested like a lot of times, and try to write as many unit tests as possible. And yeah, again, roll out your contract carefully, have many stages, and have many bounties for the hackers to uh, um, like they can point out some weaknesses in your contract. And also like also a really good practice in smart contract programming, and as well as like software programming is like try to have like a good upgradability in your contract. And yeah, other practice that you can follow is like adding of secret breakers, so like making the contracts more slow or rate limiting. Yeah. All right, so this it concludes the contract security part for now. Uh, so now let's move on. Yeah, sorry again. This is some attack exercise that you can use. So you can play with. So this is a link, and yeah, yeah, you can try to go into this link, and you see some you will see like some a vulnerable contract, and yeah, try to play with it, try to see what is like vulnerability. And yeah, um, I will include the solution in the slides and send to you guys later. Okay, so let's now discuss about the tokens. Yeah, so so what are tokens like? So actually, so unlike Bitcoin or Ethereum, like we don't need to create a blockchain to build a token. So most companies, so when they perform ICOs, they will associate the tokens as objects, like objects, like or stock of the company. So you can imagine like many companies out there, they issue tokens, but it's actually you can see it's like as the you can see as the stock of the share of the company. And the beauty of tokens like is that they can easily be built and very and like it has very standard smart contract logic behind them. So let's say so yeah, so let us see how we can build a token. So so if as you know, like the cycle of the tokens is as follows. First, you need to create the token. Then when the company already created the token, they issue it out, and then people they can just purchase tokens. And then after that, it's just like in the market, like you people can like trade the share with each other. The same applies here. Like people can just trade the token with each other. Okay, and yeah. So um, so let's see. So how can there are actually like two types of tokens. The first one is fungible tokens, and the second one is non-fungible tokens. So the first fungible tokens, like I will just discuss like the fungible tokens and non-fungible tokens in the Ethereum context here. Actually, other blockchain they also have such ones, but like the ones that stays on Ethereum, they are the most popular one. Okay, so so on Ethereum, the mostly used standard to create the token is ERC20. So ERC stands for like Ethereum request command comments. Sorry, so Ethereum request comments. So yeah, so this ERC they are the standard that people need to follow when they create ERC20 token. And yeah, they are because they can be traded with each other and have the same value, so they are considered fungible. And yeah, all so to actually to build such a token it's quite simple. You can just implement the ERC20 interface. So yeah, and yeah, so what is ERC20 interface? They are just again like they are just a common list of rules that are Ethereum tokens. So like yeah, that it implements to follow. So it means that this particular token interface empowers the developers of all types to accurately predict how new tokens will function within the larger Ethereum ecosystem. Okay, so so this is like this is yeah, the main part of the ERC20 interface. So you can notice here, so it has the total supply method. So like total token supply out there for this token, and the balance of methods. So like how much other address can, how much of like how many tokens the address has, and then we have the transfer methods and transfer from methods, and unapproved methods is like you allow someone else to spend like to spend your token on behalf of yours on behalf of you, and then the allowance like is to ask how much the allowance is, and then finally we have some transfer and approval events. Yeah, so just to lock the events out whenever something happens. Okay, and yeah, so some necessary additions to this one is yeah, as other contract is we have its own constructor, and then because like we have some let's say we need to like the let's say it needs to have some storage to store, let's say, the balances of the addresses, and then so and um like and to the list of the people that is allowed to spend tokens for an owner. Okay, so yeah, that's it's about ERC20. Yeah, some other necessary thing like you need to have the token name, you need to have the symbol, and finally like the decimals. Like yeah, so um, just for displaying purpose. Yeah, so that is for ERC20 tokens, and yeah, sorry. So some tools that you can use building for building these tokens is like um, so like even with all the functional requirements that outlined there, actually you can build a token can be made easier with online open source resources. Yeah, so actually the community that has come together to create a community-backed smart contract and the open stability tool. And here there is the code that implementing many different ERC tokens that can be reused in anyone's personal projects. And yeah, so actually you can just use the code. You can just load their code on GitHub into your own project, and yeah, you can just build the token in the span of just like several minutes. So just that simple, super easy for you to do so. Yeah. So yeah, that's it for how to build a token, like ERC20 tokens. And now let's come to the NFT, or can be called non-fungible tokens. So the one that causes or raise all the crazes out there in the market. So yeah, so what is ERC like non-fund NFT token on Ethereum? So actually, most of the NFT on Ethereum they follow the ERC 721 standard. So a non-fungible token is called so because like one token is we have a different value from another token. And you can think of term of it like when you trade the cards, like some cards we have will be more valuable than other cards. And the best example here is virtual kitties, like the one that um, the game you can search on the Google, like actually like people um, like the game of cryptos like of the cute kitties where people can just um, discover as many species of kitties as they want, and they trade the kitties, and they tried that they also like try to create a new kitty from two kitties, and they create a new species of kitty out there, and they sell it to others so people can just trade their kitties with other. And some kitties it has value gone up to like a crazy value. It can be like $100,000. And yeah, so yeah, and as similar to ERC20, implementing ERC 721 is actually very simple. Yeah, we can just use the interface that has been supported by the community. So again, some example of NFT out there is like CryptoKitties, and if you notice this one, it's actually Neon Cat, the one that has been sold for, if I remember correctly, like $160,000. Yeah, it's just a really simple, funny picture, but yeah, the author he decides to create an NFT from it, and yeah, it has gone up to a really crazy values. Yeah, so yeah, so let's see how this interface looks like in informal code. So again, so if we have some you can notice like so it has some balance. This interface has some balance. The methods to keep track of the balance of the address. It has some like and so it's count like the number of NFTs that the owner has, and then another method to keep track the owner of the NFT and other like safe transfer from other transfer methods, and we have approved method here just like to allow other participants to trade the NFT for you. And yeah, so other approving for instance, like set approval for or get approved or approved for all. So yeah, and that's it, the main methods that that an NFT needs to have. And also and finally, like there are some optional functions that you need to follow is like the name method, just the name of your collection of NFT, the symbol method, like the symbol for like an abbreviated name for the NFTs in the contract, and yeah, the token URI. So like it would contain some like URI here stands for Uniform Resource Identifier. So it would contain some links to for more information about the NFT, and then the total supply just to keep track of how many NFTs out there in this collection of NFT. Uh, the the token by index method, like so actually you can like it will send like it will return the NFT of that index in the collection, and also you can list out you can also like enumerate NFT like of, of an index and of an owner. Yeah, so by using the token of owner by index method. So yeah, so that's all about the ERC-721. And with that, it also ends my workshop today. So thank you everyone for joining the workshop, and hope you have like attain a great value out of this one. Yeah, if you have any question, feel free to like Telegram me, DM me on Telegram at William Vegan, or you can like ask ask it directly in the public group. And also, you also email me, email the club, our club at blockchain.ntu at e.ntu.edu.sg. So that's it for today. Thanks everyone.